Assalamualaikum warahmatullahi wabarakatuh and good morning. Can you guys hear me?
Yes, Doctor.
Waalaikumsalam. Yes, Doctor.
Okay, right. Wait a minute, I need to set up something. Okay, so I think everything is fine. So you guys can hear me. So okay, let's. This is our first class this semester. So we don't have any class on last Tuesday because it is a holiday. Okay, so let's see. So how do we start our class? So before we start, so this is my name. So I am Dr. Musa Muhammad Mokji, right? So that's my phone number. You already know what is my phone number. So that is my email. Okay, and I am teaching a section 3 and section 4 for SKEL 4223. So there are also section 1 and section 2, okay, by Dr. Khairul Hamimah. Right, so so those are the, so we have only two lectures this semester, okay, 4 sections, 2 semesters, and mostly you guys are from SKEM. Just some of you is from electronic and maybe from electrical power. Okay, all right, so let's see our planning first. So what is our planning for this? Right, to start with, so this is actually the planning for 21-22 semester 1 this semester. So if we look at this diagram, so we have as usual we have 14 weeks. So we have 14 weeks, with every week we have a topic. Okay, for example, this week we should actually finish signal, so discrete signal. Okay, but because we doesn't have a class last Tuesday, so maybe we'll drag a bit on the second week. But this is actually our planning. So we will catch up. So next week supposed to be a discrete time system. Okay, until the last one will be on some application of the DSP. And you can see some color coded here. So that green color is actually for topics on time domain. So I think everybody already familiar with these terms: time domain, complex domain. Last time it is S domain, right? In signal and system last time. So everybody already learned signal and system. So you have a S domain. So but now in discrete, we change it into Z domain. So that rate is actually a Z domain, the complex domain, and then we have a frequency domain. Okay, so if we look at this topic, so normally most of it is actually you already learned these topics, but now we are going to on a different because last time mostly is analog, so now we change it into discrete. So you have learned this frequency response on what we call a Fourier transform. So already learn what is a Fourier transform. In LTI system, we have a convolution. So you already learn what is a convolution. We have a filter. So you already learn what is a filter. So you have learned most of these terms, but now we just changing it into a discrete version of it. Okay. So those are the planning, and this is some what we call milestones. So you should achieve this thing, right? After this week, as you're supposed to have, you're supposed to know how to plot signal. And then at some weeks, you already know how to perform convolution. Until the last one, you should be able to design a discrete filter. Okay. So, and these are our tests. So we have 2 tests. So you might want to jot this down. So test 1 will be on 16 November. So that one is on week 5. So now we are week 1. So we have another 4 weeks. You will have a test 1. Right, test 2 will be on 30th December. All right, test 1, test 2. And then, so this is our assignment. So we actually have 2 phases of assignment. So this is a phase 1. So we call it jigsaw activity. So later you will know what is a jigsaw activity, or maybe you have done this activity before from other classes. So, but this is another activity. So we will do a jigsaw activity for the first phase of the assignment. If you look, if you read here, so this is what you need to do is create a visual notes. It's like a notes, your own notes, mind mapping notes for several MATLAB or Scilab function. But this semester we will focus on MATLAB only. Okay, we're not going to do Scilab, so we will focus on MATLAB. Okay, the whole class will do on MATLAB function only. Okay, means that this is coding. This is coding. And the second phase is you need to do some filter design, because after you learn something on MATLAB coding, so you need to code to do a filtering. Okay, so the first phase is 3 weeks. The time is 3 weeks, and then the second phase is also 3 weeks. Okay, we'll go through this later in detail later. Right. So for now, we just know that we have 2 phases of assignment, and each assignment is actually 3 weeks. And you need to be your time management needs to be very, very good, because at this because most of you SKEM, so you are in fourth year's first semester. At this week, which is a week 13, you will have a capstone presentation. Okay, so I'm sure most of you SKEM is actually taking capstone. This is a very challenging semester. So at this week 13, you will have a final presentation for capstone. And week 14, you will have your FYP1 presentation. FYP1 presentation. Right? And these last 3 weeks also for this course, which is a DSP, you should finish your second phase assignment. So please make sure you manage your time properly. Right? Because fourth year semester 1 is a very challenging time. Unless you are SEEL or SKEL or maybe Power, maybe you are still in 3rd year. Okay, it doesn't have that capstone and final year project with you this semester. Okay, so any questions so far? Any questions? So those are our planning for this semester. All the topics, the milestone, the tests, and assignment that you will have. Right? Hopefully it's clear. I think it's clear. So no question means clear. So, but if you have any questions later, you can ask. You can ask the question, or you can just write your questions in the chat section. Okay, so we have a chat section in this Google Meet, so you can just write down your question there. Okay, all right. So now it's 10:17. So we will start our. If there's no questions, so we will start our topic. So our topic, the first topic will be a discrete time signal. And okay, before that, so any materials you can get from e-learning. Okay, so this is the e-learning. So everything is here. You can get your course information, equation list later. I will explain it. The class notes. So MATLAB notes, even DSP with MATLAB notes. Okay, so this is a separate MATLAB notes. So this MATLAB notes, I think you already seen it before in your first year scientific programming. Okay, you have taken a scientific programming in first year. So actually, this is the notes. So you can maybe you might need to refresh some topics. Okay, because we want to use a MATLAB. But this is very specific. This is very specific. So this is DSP with MATLAB. Okay. So we have topics, 14 weeks topics, and this is a week by week topic, which is approach on MATLAB. Right, so you might want to read that one. I'm not going to go through these notes in class, but you need to read it because you have assignment on MATLAB. Right? Okay, so and most of it's in class, so we will learn these things. So we have a lot of these are the 13 weeks notes. Okay, we have 14 weeks, but we're going to cover the notes is on 13 weeks. Right, and then we have a DSP charts. We can look at it, and this is a DSP concept of mapping. So this is more like a visual notes because those are examples of how do you do mind mapping, some visual graphically notes, because you need to do that on your assignment also. Okay, so sometimes it's not easy to do it, but it will be very good if we can make what we learned graphically. Right, so that's what you need to do in your assignment later. And for now, okay, what else? Let's see. And from time to time, so actually we will have some YouTube video. You can see it here. So this is like sampling, analyzing. So I'm not going to cover this in, I'm not going to play this in class, but this is some additional knowledge that will be very useful to you to understand what we're going to learn in class. Okay. Okay, now let's start. So what will be our topic for today is discrete time signals. So this is a part 1. So next week we will have a part 2. Okay, we will finish next week on part 2. And this is past courses that you have learned, which is related to DSP, the digital signal processing. So you have learned circuit theory, the RLC circuit. Okay, so it's related. It's related. Engineering mathematics 1, so you have learned about sequence and series, convergence. So we're going to look at that again. Differential equation, you have a Laplace transform, Fourier series. So you're going to look at that again in the discrete form. Laplace transform and Fourier series is for analog version. Okay, analog version of a signal. But when we go to a discrete, so we will have a Fourier transform. We will have a Z transform. Not a Laplace transform anymore, but we're going to convert that into a discrete version. Digital electronics, so we need to know logic, okay, because we have a lot of things here. Digital system, there's a sampling, very, very important, because we are learning about digital signal processing, which is digital. When we do digital, first thing is supposed to be the sampling. Okay, actually you have learned what is a sampling, what is a quantization, so what is a system in digital system. See, so most of the things you have learned from your previous courses. So this DSP course is actually this is an easy course because we just what we do is we are repeating again most of these things, but in a discrete version only. Right? We are going to repeating what is sampling, repeating what is a Fourier, those kind of things. The signal and system. So you have a continuous signal Laplace transform, Fourier series, RLC circuit again. So you have circuit theory, you have RLC circuit, and in signal and system you have a RLC circuit. Anyone remember what you do with the RLC circuits on signal and system? So anyone remember? So let's hear some voice, or maybe you can write down on the chat section.
Well, to be honest, Doctor, it has been 2 years since
Has
the
that been 2
signal
years?
system course.
Yes, of course. So so this is where you need to revise everything. Okay, so this is at least this is a 3rd year course, or this is a 4th year course. So this is where everything will be connected. Everything will be connected. So what is the RLC? At least you know what is the R, L, and C. Anyone know what is the R, L, and C? Anyone? So maybe comes into your mind what is the R, L, and C? Even though you do not know what is the, you don't remember what is the RLC circuit. So at least what is the R? Electrical, electronic engineers, right? So resistor, inductor, capacitor, yes, that one. Okay, that one. We're not going to do any RLC circuit anymore, but we're going to compare something with those RLC. So no worry. There will be no test, exam, or assignment on the RLC circuit. But we need to know what is the difference. What is the connection? Okay, what is the connection? And this is very important. Microprocessor. Microprocessor. You have learned about processing units. You have learned about memory, the ROM and RAM. Okay. Anyone remember? What is the difference between ROM and RAM?
RAM is a fast read memory which stores the data for a shorter period. Instead of the ROM, it stores the data for a longer period.
Yeah, okay, true. Okay, so you save your data is actually on ROM. Okay, RAM is just it's for processing. Okay, it's not fixed. So every time you're on your computer, so it will change. Okay, so ROM lose data when power off. Yes, true. Okay, your hard disk is actually ROM, and hopefully everybody still remember. So when we have a ROM and RAM, so you have how do you store data? And one of it is there is an address. Okay, there is an address. So every storage there is an address. Okay, so those things is actually why we need to understand those things is because when we do a discrete signal, everything will be saved into your ROM. Okay, so this is where we need to really understand. So how does the signals looks like? So how do we treat the signal? If it is analog, so how do we treat the signal? So how does the signals looks like? Okay, so okay, I'm going to skip this one. So this is just some introduction. What is a signal? Signals, I'm sure you have seen a definition of signals many times before, but let's read this. Signal is defined as any physical quantity that varies with time. Okay, either time, space, or any other independent variable or variables. So either it is if it is in this course, most of the time you're going to deal with time. You're not going to deal with space or any independent variables. Okay, so what does this mean? Signal is defined as any physical quantity that varies with time. So this is where values will change with time. Okay, so the x-axis will be time. Your value of your signal will be on y-axis. A discrete time signal is a series consisting of sequence of quantities. See, so you have done one question before we start our class. Okay, that sequence. So that one is a sequence. So a discrete time signal is also a sequence. Okay, so if you really understand what is a sequence, so that will be very good. And you need to understand what is a sequence. So in other words, it is a series that is a function over a domain of a discrete integers. Each value in the sequence is called a sample. As most of the signal encountered in science and engineering are analog in nature, a process on converting the analog signal to discrete signal is needed. So this process is called digitization. Okay, so which consists of sampling and quantization. So this is actually digitization. Digitization is, if we look at here, so we have this gray line. So assuming that one is the analog signal, so we need to digitize it. We need to digitize it. Okay, so in your previous courses, a digital system, so you have learned what is actually quantization and sampling. Okay, so what is the difference? Both are actually digitization process. But converting continuous value to discrete value on horizontal axis, that one is called sampling. Okay, we have two axes here. So this is the y-axis. Oh, sorry, this is the x-axis. And this is the y-axis, of course. Okay, anything that you do, making it from a continuous to discrete, so on on x-axis, so we call it sampling. So digitization on the y-axis, we call it quantization. Okay, but in this course, this semester, we're not going to focus on quantization. So we're going to just assuming that our discrete signal is going through sampling only. Okay, so even though there is a quantization, but we're going to focus on the sampling alone. So hopefully you guys still remember this thing, right? Let's see. I have this one. Okay, so let's say we have, this is a sampling. So if we have a signal, this is a very simple signal. So this is what we call a single frequency signal. So this is a cos signal. Okay, this is a cosine signal. And what is this? This is an analog signal. And how do you know this is an analog signal? Because the x-axis is in time. Okay, which is second. So how do you read this? So you read this, this is a 0 second, this is 1 second until 10 second. And what is the function? The function is a x of t. Okay, if we do a x0, so it means that at this point, so x0 is 1. What is a x1? x1 here, so you'll get 0. What is the x 0.1? So you will need to check at 0.1 here. Okay, then you will get some value. So, or you can solve a cost function. Okay, so what is a cost function? So cost function is, hopefully I can write this. So this is actually xt equals to cos 2 pi f t. Still remember this thing? The cosine. So you should have a 2 pi f t. Okay, so what is the capital F? Anyone? Remember what is the capital F? T is very clear, T is time. So we're going to look at a lot on this thing. What is capital F? No worry if you are wrong. Frequency, yes. So that one is a frequency. So what is the unit of a frequency? Hertz. Very good. So that's a good start. So this is a signal. So what is the frequency? What is the F? So we do a little bit revision.
F is 1 over omega?
Yes, 1 over Ts actually.
1
1
T.
hertz. Yes, 1 over T. Okay. So someone answer 1 hertz. Any other answer? And yes, this is actually 1 over actually Ts. Sorry, TP. time period. So how do you compute TP? So it's a one cycle. So you start here 1, and then goes here. It repeats, right? It repeats. Okay, so 0.25 hertz. So 1000, you vanish, says 0.25. Alif, yes, that one is true. That one is true. Because this is actually 4 seconds. The TP is 4 seconds. 1/4, you will get 0.25. Okay, so that's the TP. So this is what we call a single frequency signal. A single frequency signal can be either cosine or sine. Okay, cosine or sine. So, and this is xt, which is analog. So what we do is we want to do sampling. And when we do sampling, what is the most important thing is we need to know what is the frequency sampling. Okay, so this is still a revision from digital signal last time and signal and system. And when we do this, fs, let's say we have a fs equals to 1 hertz. So what does this mean? It means that you want to have 1 sample every second. Okay. So for analog signal, so how many samples do we have? So actually we have infinity number of samples. So, and of course, we cannot store this analog signal. We cannot store that. Okay, so if you want to store it in your PC or any storage device, so you need to sample it. Okay, you need to sample it. Okay, so this is one example. So we want to sample using frequency sampling 1 hertz. So 1 sample every 1 second. So then our xt now becomes xn. Okay, we're going to use n here. We're going to use n. And we're going to fix a notation. This is analog. So we are using a normal bracket. Okay, this is what we call a normal bracket. This is a square bracket. What is a square bracket? So okay, so let's do that. Sorry, this is a normal bracket. Okay, and then this is a square bracket. So this is a square bracket. So for analog, we will use a normal bracket. For discrete, we're going to use a square bracket. So the first value at a 0 second. So this is s is a second, and n, what is the n? N is a sample, because when you do sampling, even the name is a sampling. So actually we are taking samples. Okay, sampling is taking samples. So what is the first sample? So but we are indexing it using starting from zero. So this is a sample at index 0. Okay, hopefully not you don't confuse with that one. This is the first sample, but we are indexing it with index 0. This is the time. This is at 0 second. This is at 0 seconds. So what is our xn? Our xn is 1. Okay, because what will be the next sample? So we will take a next sample because we want to sample it every 1 second. So this is a frequency sampling 1 hertz. So after 0, so we wait after 1 second, and then we take another sample. So which is now at time 1 second. So we will have a new sample. The value is 0, and the index, we put it as a 1, because we start our indexing with a 0. And then we go to next sample, which is at 2 seconds. We take another sample at 2 seconds, and then we take another sample at 3 seconds, and then at 4 seconds, and then the rest. Okay, so that's how we do sampling. And what is this? So this is when we are setting our frequency sampling equals to 1 Hz. Let's look on another situation. So now we want to use frequency sampling equals to 2 Hz. Okay. So when the frequency sampling equals to 2 Hz, so what does that mean? So it means that we want to take 2 samples every second. 1 Hz, 1 sample every second. 2 Hz, 2 samples every second. So if you have a 1 kilohertz, means that you're going to take 1,000 samples every second. Okay, and that's quite normal. 1 kilohertz is quite normal. So your if you still have your audio CD, okay, I'm sure not many of you still have a audio CD. Okay, that CD, that round things. Okay, so that one is the sampling is I think it's a 44.1 kilohertz. So means that you will have a sample 44.1 kilo. So 44,100 samples in 1 second. Okay, that audio CD. I think you guys still know what is the audio CD. So there's a circle. Okay, at the middle. Okay, so when we do this, so our first sample, the first at time 0, so still the same thing. So we have, because we are starting at the same point. So but the next sample, you will take the next sample at 0.5 second, right? But now our indexing is not 0.5 because this is our indexing on sample. So this is index 0, then this one will be index 1. This one will be index 1. And the next will be on 1 second. So this is where we have every second you will have two samples. 2 samples, 2 samples again, 2 samples again. So after 10 seconds, you should have at least, you should have 20 samples. Okay, this one, after 10 seconds, you should have 10 samples. So this one, you'll have 20 samples, twice the number of samples. Okay, you go down the next sample, and then the next sample, and the rest. Okay, because this is a twice of this, so you will have twice the number of samples. Okay, so we can see that. So this is index 0, 1, 2, 3, 4. This is 0, 1, 2, 3, 4, but the value is different. Okay, because we are taking the sample at different position of time. Okay, any questions so far? Because this is quite straightforward. Still straightforward because sampling, you already know what is a sampling. We're just doing some revision on sampling. And this one is just going to read it. Classification of a signal. So we have a continuous time and discrete time. Last time, signal and system, you have learned on continuous time. So this semester, you're going to learn about discrete time signal. And then there is a periodic and aperiodic. So, and you have learned this from a signal and system last time. Periodic is like a sine and cosine. Aperiodic is there's no repetition. There's no repetition from minus infinity to infinity of time. Okay, and then deterministic and random. This is, we're not going to cover this. So if you are really interested in signal processing, so you can take another subject, which is advanced DSP. So then you will learn about random signal. Okay, the one that you're going to learn is only on deterministic signal. So this is a more detail on what is a sampling. So the sampling process can be viewed as actually such this. So T, because we have, if you look at this, we have S and we have N. Okay, And this S in second is actually a T. Okay, time. And N is actually also time, but indiscrete. Okay, but what is the relationship? The relationship is actually T, that's time in continuous, is actually equals to NTS. NTS is a sampling time. Okay, what is the sampling time? If you have this TS, and TS is actually equals just 1 over Fs, our frequency sampling. So if Fs is equals to 2 Hertz, then your TS will be simply 0.5 second. It means that you're going to take a sample every 0.5 second. So that is a TS. And there is a sampling theorem. So how to get enough sample? So how to get enough sample? If we look at this one. So do you have enough sample? If we are sampling it using 1 Hertz, so is it enough? If we are using 2 Hertz, is the sample enough? Enough for what? Enough to represent the signal. Okay, so the answer is based on this Nyquist theorem. What Nyquist says, your frequency sampling should be greater than or equals to Fn. And what is the Fn? Fn is the highest frequency component in the signal. Looking back to this example, so we have seen that what is the frequency of this signal? So it is 0.25. Right? Everybody answer that one. So the F, the capital F, the frequency of this signal, because the TP is 4 seconds, the frequency is actually 0.25, and we are choosing Fs equals to 1. And 1 is actually 4 times of 0.25. So actually 1 Hertz is already enough, because what we need is a minimum 2 times. 2 times of the 0.25. So then actually you can pick 0.5 Hertz. So that will be enough. So that's what a Nyquist theorem says. Okay. And why this, the one that I mentioned, the audio CD, the sampling, the frequency sampling is a 44.1 kilohertz. So why is that? Because a half of 44.1 is actually 22.05 kilohertz. So what is actually 22.05 kilohertz? So that one is actually for normal human. So that's the maximum that we can hear. So that's the maximum. Actually, the maximum that we can hear is a little bit lower than 22.05. So maybe at 20 kilohertz. So that's why they are sampling it, because that one is for audio, right? Audio CD. So because most of human can only hear up to 22.05 kilohertz. So then they are doing the sampling at 44.1 kilohertz, double the maximum frequency. If we are looking at a different example like ECG, so you're going to do a ECG for the assignment this semester, right? So for ECG, the sampling, mostly the frequency which is effective is I think up to 100 Hertz. So using a 200 Hertz sampling frequency is enough for ECG. So that's why we need to pick frequency sampling based on the signal itself, right? So that's the formula. So we have seen this. And this is how we write our signal. So we have seen it here also. Okay, so write this xn. So what is the value? So it is just 1, 0, minus 1, 0, 1. If we use fs equals to 1 hertz, so what is our discrete signal? Our discrete signal is 1, 0, minus 1, 0, 1. So that one is after up to n equals to 4. But of course, you need to continue. So 1, 0, minus 1, 0, 1, 0, minus 1, 0 again, 1, 0, minus 1. So that's the sequence. Okay. So discrete signal is actually how does it looks like? So it is actually a sequence of values. A sequence of values. And what is this? So what is this? This arrow, where the arrow shows the position at n equals to 0. Okay, so that one. So of course, because we can start our signal theoretically, we can start our signal at a negative time. So we can do that theoretically. But of course, practically, normally when we start recording our signal, so it will start at time equals to 0. Right? But theoretically, we can do that. We can start at time negative second. Okay, so but that's why normally, so we will start this index. The first value is actually index n equals to 0. So everyone needs to know now our discrete signal is actually just a sequence. It is a sequence. And when it is a sequence, this is the example when we plot it. So at n equals to 0, the value is 2. At n equals to 1, the value is 1. At n equals to 2, the value is 3, and so on. So why we call it discrete time? See, if we go back to our title, we are very specific. So we call it discrete time signal. We don't call it discrete signal. Okay. So what it means is when we learn this digital signal processing, so one of the important when we do analysis and everything, so the time is supposed to be discrete. Okay, we are focusing on that. We are looking at a discrete time. So it means that the x-axis supposed to be discrete. This one. That n. So what is n? So what is n? N is discrete time. T is what we call a continuous time. Okay, originally every signal is actually, most of it is a continuous. So this is where we are recording, we know when the time is, which second is being recorded. But after we do sampling, so everything will be changed into a discrete time, which is n. So how we do that? So this is an example of how we do it. So no matter what is the signals, so actually we are converting this time in second into a discrete values. Okay, into a discrete values. So that is our signal. So this is our first lesson. So we need to know what is actually discrete time. Right? Any questions? And every time we are recording or doing a sampling of a signal, so you are having two things. One is the n, another one is the value. So you need to see both things. Okay, so this is where You have a value 2. Where is the value 2? Value 2 is at n equals to 0. Value 3 is at n equals to 2. Either you can plot it this way, or you just write it such this as a vector. In math, we call it vector. A sequence of numbers, we call it a vector. And even though we doesn't write the index, okay, as a question, the IQ test questions, the 2117 and what is the next value. So we don't really write the index. So, but you need to see your index. So this is index 0, this is index 1, index 2, index 3, index 4, index 5. Okay, because it is in sequence. It is in sequence. It's not a random value. It's not a random value. So when it is in sequence, so this one already fixed. When you see 2 and this arrow, so you already know that this is at n equals to 0. That value is at index 0. And when you see this, because this is after this is 1, 2, 3, 4, 5, 6, but because we start at 0, so this is a 0. What is the sequence? The sequence is 0, 1, 2, 3, 4, 5. So immediately you will know that that value 1 is actually positioned at index 5. Okay. So let's see another thing. Last one for today. So when you do xn equals to, let's say I'm just going to just copy that one, 213001, 213001, and let's say this is just a small portion of a signal that you record. Okay, so maybe let's say this is temperature value. So you have a temperature sensor, and then you record it, and then you record it. So when you do recording based on some sensors, maybe it is an audio, maybe it's an ECG, maybe it's a vibration a value, so anything. So maybe it's a sonar. So everything is a signal, and then you record it. When you do recording it, where does it go? So you have a device, right? You have a device, you have a sensor, and then you use, let's say, Arduino. So where does these values go? Anyone can answer that? When you do record, where does it go? Where do you save it? So in ROM. Okay. Yes, that's true. Very good. So it will go to your ROM, and we are having, as I mentioned, as I said, every value when you look at these values. So you should have two things. One is the value itself. What is the value itself? Another one is the index. So this is index 0, 1, 2, 3, 4, 5. So this is where when you have an address, so you have address, okay, memory address. So maybe you will put 2 here, and then this is address 0. And then you will have address 1, address 2, address 3. You put your value here, and then 3, and then 0, another 0, and then 1. So hopefully you can recall this. We have an address. So when you have a memory, when you write a value to a memory, so actually you are writing it into a certain address, Okay, so actually that addresses, those address, so we are actually putting it in sequence. So that will be your index. That will be your index. But of course, we need to understand that, because now we will know that okay, our data is there. Our data is there. But of course, when we use the MATLAB is a higher level programming. It's not a very low level programming. If you do a microprocessor, the one is a very low level programming. So you need to know really exactly know where's the address. On MATLAB, it is a higher level programming. So it doesn't need to know where is the address value. So when you read a value, so it will give you this value, but you should know what is the index. You should see what is the index. Okay, so that is what we call a discrete signal, a discrete time. Specifically, we call it a discrete time signal. Okay, that's all for today. So just some words from Scott Adams. Maybe you have heard this. Engineers like to solve problems. So if there are no problems handily available, so they will create their own problems. A good problem. Okay. So hopefully we have those spirits. So we'll continue this one later next week. So any questions? So today we're not going to have any attendance. Next week we will start the attendance. Okay, because what I see is you guys are still doing insert and delete process. So maybe some of you will leave this class, and maybe some other friends will join our class. So I decided that the attendance, we will start attendance next week. Okay, where the list will be stable. Okay, so last call. Any questions? Any questions?
Doctor, can you
Yes.
explain the quiz again? I don't understand the solution.
We'll discuss this
No,
later.
not this one. The one you put on the WhatsApp.
On the WhatsApp. Oh, okay, right. Right. Let's see. Let me open the WhatsApp class. Actually, any of the answers, which is a logic like this one. Yes, this is fine. This is good answer. It's acceptable. This is also acceptable. But the easiest solution is actually from this one. Right? This one. So this is actually the easiest solution. And so what is this? So if you look at this solution, see you have current value. So you have the values. You have the values. And then you have I. So I is actually index. So you have the sequence. You have the index. So this is what I'm trying to, hopefully everybody can see it. So whatever the solution that you do, like this one also, so there is an index. So there's a 1, 2, there's a 1, 2, 3, 4. Those are index. And of course, the other one, which is this one. So you can see the index also here. So this is 1, 2, so not here. So there's somewhere, I think from here. 1, so this is actually 1 multiplied by 0.5. 2, 3, 4. Okay. So what I mean is if you have a sequence and you can see there is an index, so that's a good sign that you will understand the DSP. You will understand the DSP. So we can, so this is actually, this is a quite complicated solution. Right? This is a quite complicated solution. So that's why I'm asking here, interesting. So if I hope someone can write that in a single equation. So if you can do that, means that will be a very good. So you have a strong mathematics basic. All right, but again, so this is actually the easiest solution. So what is the x? X is actually equals to the previous that one. You need to multiply with the index. You need to multiply with the index and then minus 1. Okay, because you already asked. I think this is the one. I did that one also. So this is the index 1, 2, 3, 4, 5, 6. But in this solution, the answer is 34. Okay. So 2 multiplied by in the index 2, and then minus 1 becomes 1. And 1 multiplied by 2 is actually 2 minus 1 becomes 1. And then this is just multiplied by 3, and then minus 1, you get 2. And then again and again, so on and so on.
Wait, sorry, Doctor. Isn't the index starting from 0?
Yes, of course. That's a good question. So in this engineering world, okay, and coding, when you do a programming, some people start with 0, some people start with 1. MATLAB start with 1. A C language, Python, they start with 0. Okay, means that you can either start with 0 or 1. You need to be very careful on that one. Especially when you do MATLAB, MATLAB doesn't start with 0.
Okay. All right.
MATLAB start with 1. And these questions, so because the one who designed the questions says that I want to start the index with 1. So it's up to that person. Okay. So there's no right or wrong whether you start with 0 or 1. What is consistent? The sequence needs to be increasing. And 1 after 1 must be 2. You cannot do 1, 2, and then 4. That's not indexing. We don't do indexing that way. What is the value to start? We can change that. But the sequence needs to be followed. Okay? Any other questions? So that's the lesson from this IQ test actually. So you need to see if you have any sequence of values, you should see the index.
Got it. Thank you, Doctor.
Okay, I think no other questions. So that's all for today. Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera. Good afternoon. Still morning, I think. Good morning. So we'll see you guys again next week on Tuesday. Right? Bye.
Thank you, Doctor.
Thank you, Doctor. Assalamualaikum.
Thank you, Doctor.
Terima kasih, Doktor.